Hello children, welcome to my channel. Today in this video we are going to discuss about probability, random experiment. You might have performed so many experiments in science and you have seen that if an experiment is repeated again and again under identical conditions, it gives us the same result every time. For example, suppose you want to find the value of g, acceleration due to gravity at a particular place. If you repeat these experiments again and again, every time you will get the value of g same. But there are few experiments which are being repeated again and again under identical conditions, but they may not give you the same results every time. So, these experiments are called random experiments. For example, tossing a coin. If you toss a coin, you cannot predict whether head or tail will come. Rolling a die. Similarly, if you draw a playing card from a deck of 52 playing cards, so these experiments which are being performed repeatedly under identical conditions do not produce the same result every time. So these experiments are known as random experiments. Now, outcomes. Possible results of a random experiment are called outcomes. For example, tossing a coin. If we toss a coin, either head or tail will come. So head or tail are the outcome of the experiment tossing a coin. Similarly, rolling a die, possible results are 1, 2, 3, 4, 5 or 6. So 1, 2, 3, 4, 5 or 6 are the outcomes of rolling a die. If we toss a coin twice or two coins are tossed simultaneously, possible results are HH, TH, HT, TT. So these are the outcomes of an experiment tossing a coin twice or two coins tossed simultaneously. Next definition is sample space. A set of all possible outcomes of a random experiment is called sample space. It is denoted by S. Let us consider few examples. Example 1. Rolling a die. What will be the sample space? It is a set having 6 elements. Experiment number 2. Tossing a coin thrice or 3 coins tossed simultaneously. Sample space S is equal to all 3 heads, 1 head and 2 tail. So head at first place, in second head in the middle, and third head in the last. Then tail, 1 tail and 2 heads. So tail at the first position, tail in the middle, and tail at the last, and all 3 tails. Example number 3. A coin is tossed if outcome is head. Suppose outcome is tail, then nothing to do. If outcome is head, we throw a die and die shows up an even number. So first, if die shows up odd numbers, so H1, H3 or H5. But if die shows up even number, a die is thrown again. So suppose even number is 2. For this, die is thrown again. So H21, H22, H23, H24, H25, H26. Similarly, even number is 4. So H41, H42, H43, H44, H45, H46, and even number is 6 also, so H61, H62, H63, H64, H65, H66. Next definition is event. A subset of a sample space associated with a random experiment is called an event. Clearly, event is a subset of a sample space. Example 1, let us consider a random experiment throwing a die. What will be the sample space? 1, 2, 3, 4, 5, 6. Suppose E1 is the event getting an odd number. Then elements of E1 will be 1, 3, 5. You can see clearly that E1 is the subset of sample space S. E2 is the event getting a number less than 4. Number less than 4 are 1, 2, 3. So, again E2 is the subset of sample space. Example 2. Let us take a random experiment of tossing a coin thrice, or 3 coins are tossed simultaneously. So this is the sample space for this random experiment. Let us consider the event exactly one tail. Exactly one tail means there will be only these 3 elements: THH, HTH, HHT. So again we can verify that E1 is the subset of S. Let us take next event, at most 2 heads. It means not more than 2 heads. So we will take the cases of no head, 1 head and 2 heads. Now we can easily verify that E2 is also the subset of sample space. Next is types of events. First is simple or elementary event. If an event has only single element of the sample space, it is called a simple or elementary event. Let us take an example of throwing a die. What will be the sample space? 1, 2, 3, 4, 5, 6. Then events having a single element of this sample space, that is E1 equal to 1, E2 having 2, E3 3, E4 4, E5 5. All these events are elementary or simple events. Second event is compound event. If an event has more than one element of the sample space, it is called a compound event. In this random experiment of throwing a die, the events E1 1, 3, 5, E2 2, 4, 6, E3 5, 6, etc. are called compound events because they have more than one element. Next event is sure event. Let S be a sample space and we know that every set is a subset of itself. So S is also the subset of itself, that is S. And by definition of events, every subset of a sample space is an event. So S being the subset of itself is also an event. So S is called sure event. In other words, every sample space is a sure event. Let us take an example of tossing a coin twice. What will be the sample space? HT, TH, TT, HH. This is a sample space and event E, which is equal to the sample space, that is having the same elements as in the sample space, is a sure event. So clearly the event E having the same elements as in the sample space is a sure event. So E is a sure event. Let us consider a random experiment of throwing a die. Sample space will be 1, 2, 3, 4, 5, 6. Event getting numbers 1 to 6, that is 1, 2, 3, 4, 5, 6 is a sure event. Next is impossible event. Let S be a sample space. We know that empty set phi is a subset of every set. So phi is a subset of S. And by definition of events, every subset of sample space is an event. So phi is also an event and therefore phi is called. Let us take an example of throwing a die once. What will be the sample space? 1, 2, 3, 4, 5, 6. Let event E is getting a number greater than 7. Clearly, event E has no element. So event E is here impossible event. Let us take another example of tossing a coin twice. Sample space will be HT, TH, TT, HH. Event E getting 3 heads. So, which is impossible. So, E is an impossible event. Next is occurrence of events, or you can say algebra of events. What is the meaning of not, and, or events? So let us take an example. A die is rolled. Then sample space will be 1, 2, 3, 4, 5, 6. Suppose A is the event getting an even number. Then what is A? Even number, that is 2, 4, 6. And B is the event getting a multiple of 3. So that is 3 and 6. Now A or B. A or B means A union B. And what is A union B here? 2, 4, 6 and 3, 6. Union of these two is 2, 3, 4, 6. And then A and B. Event A and B means A intersection B. And what is A intersection B? Means common elements, that is only 6. Now meaning of not A, you can say it as A dash or it is A bar. The elements X such that X does not belongs to A, X belongs to S. Event not A or A dash or A bar, meaning is the same. Complementary event. Complementary event. Not A or A dash or A bar means it contains the elements of X such that X does not belongs to A but belongs to sample space. So this is equal to A is 2, 4, 6. So we have to take those elements which does not belong to A but belongs to S. So the elements other than 2, 4, 6 in S are 1, 3, 5. So not A is 1, 3, 5. Similarly, not B, elements other than 3, 6 in S are 1, 2, 4, 5. A what? Not B. It means A minus B. A but not B means A minus B. That is the elements like X such that X belongs to A but X does not belongs to A. So X belongs to A, that is 2, 4, 6. 2, 4, 6. But we will not take 6. Why? Because it belongs to B. But as per definition, A minus B means does not belongs to B. So this is like this. Similarly, B, what not A? It means B minus A. B minus A, elements belongs to B but not A. Belongs to B, that is 3, 6 but not A. So we have to remove 6 from here, only 3.